Welcome to Certain to Omega Shan Tapeshua. In this video, we're going to look on functions. So we have to keep this video simple so that you can understand. So what is a function? A function is a rule which maps a single number to another number. So I'm going to give you an example. We're going to illustrate this using some sets. So I'm going to draw two sets right here. And I'm going to call this set A and this set B. So on set A, we have three numbers. We have 3, 5, and 7. And on set B, we have 9, 25, and 49. So what I'm going to do, I'm going to map 3 to 9, 5 to 25, 7 to 49. And as you can see, there's a relationship. As you can see, 3 is a factor of 9, 5 is a factor of 25, and 7 is a factor of 49. Okay, so this relationship is what we call a relation. Like we said 7 is a factor of 49. So as you can see, so set A, which controls everything, is what we call the domain, and set B, which is being controlled, is what we call the codomain, right? And this type of relationship, we call it a function. Okay, so let's say a given function. Normally we give a function, let's say f of x equals root x. So you know that we only have square root of positive numbers, right? Starting from 0 to 1 to 3 going on. We can't have the square root of a negative number. So that means x, we have values from 0 up to infinity, right? So this is what we call the domain of x. So that means what we need inside the square root are the values from 0 up to infinity. So we're writing the domain, we write x should be greater than or equal to 0. Yes, because the square root of 0 is equal to 0. So now we're going to look on natural logarithm of x. So now what we need numbers which are greater than 0, right? X should have numbers which are greater than 0, because you can't have the natural logarithm of 0 or a number which is less than 0. So that means x ranges from 1 going up. That means the domain for this function, we say x is greater than 0, right? So this set of values, x is greater than 0, x is greater than or equal to 0 for the first function, x is greater than 0 for the second function. That's what we call domain, right? Okay, so what we normally do, if we look at a graph, you can see the domain from the graph, right? But in some cases, the graph that we are going to be given will be complicated. So that's why we use the general rule, right? Okay. So I'm going to draw the graph of Linux. I hope you're familiar with the graph. So this is the graph. This is what the graph looks like. Okay. So as you can see that the graph doesn't touch the y-axis, but it stays close on the y-axis. And the graph cuts the x-axis when y is equal to 0. So that's why we can get our domain, right? As you can see, all the values of x are on the positive side, right here. As you can see, right? We have nothing right here, right? So that's why we come up with this domain, right? So there's an important thing that we have to look at. We have to look at what we call the range. So for the range, I'm going to write an example. Let's say we have the graph of f equals to x squared. And we're told that the domain for x ranges from 0 to 3. Now we need to calculate, or we need to find the range. Okay, so I want to do this in a very simple way. So let's draw a table of values. So x ranges from 0 to 3. So that means when x equals to 0, f of x equals to 0. Just a simple substitution, right? When x equals to 1, right here, we put 1 right here. And you know that y is going to be equal to 1, right? Don't get confused right here. Let's sketch the graph. Okay, you should be familiar sketching the graph. If you don't know how to sketch the graph, I have another video. Just check the link in the description where I illustrated curve sketching, right, and all the transformation that you need. But if you don't know, okay, let's continue. This one will be equal. This one will be easy, right? Okay, so this is going to be the graph, as you can see. So the graph of x squared should extend up to here, but from our domain, as you can see, we just need the positive, right, from 0 to 3. So that's why we have considered this part, right? Okay, so from here, as you can see, let's look at the maximum value of y. Okay, so this is maximum value of y and the minimum is 0. So as you can see, the values of y ranges the minimum right here to right here. This is what we call the range. So ranges from 0 to 9. So that means we can write that range is from 0 to 9, right? Okay, that is the range of our function. Now let's consider another example, right? So we're going to look at a cubic function right here. This is a common graph, so you should be familiar with it, right? This is a cubic function, right? So let's look at the domain. Okay, so you just need n values greater than negative 2, right? So let's sketch the graph, right? Okay, so these are our axes, right? So for the graph, you should be familiar with this graph. So this graph looks like this. Yeah, it continues to go up right here and it continues to go up right here. Okay, but we're told that we need values starting from this region, right? Okay, so let's sketch the graph. So this is going to be the graph. So as you can see, what is the minimum value and what is the maximum value of the graph, right? So as you can see, this one is going to be the minimum value. So I'm just going to substitute right here. So when x equals negative 2, what is going to be the value of y? So the value of y will be equal to negative 8 right here. So that is going to be the minimum value. But as you can see, the graph keeps on going up, right? So that means we're not going to have the limit. So the limit is going to be infinite. So infinite is just a big number, right? That is infinite. So for the range, we know that the range is from negative 8 up to infinity. Okay, let's consider another example. And this one is going to be more challenging, right? Okay, so you can try this. You can just pause the video. So want to find the range. Let's see the domain that we're given. We're given the domain from 0 to 4. So we need to sketch the graph. Okay, so let's draw the table of values from x ranges from 0 to 4 and for y. And I say that don't get confused by calculating these values, but just putting when x goes to 0, everything goes to 0, and we're going to be left with 6, right? When x goes to 1, we're going to have 1 right here, minus 5, and that is going to be equal to negative 4 plus 6, and that's going to give us 2. That is just a simple substitution. Okay, so let's draw the graph. Okay, so this one is going to be the graph, right? If you don't know how to draw the graph here, don't worry. I have a video like I told you, check in the description, just complete some space. Okay, so this is the graph. Yes, you can see that for the maximum value we have 6 right here. Okay, but the problem is going to rise for the lowest value, right? So this one is going to be the maximum point and this one is going to be the minimum point, but we don't know what is the minimum point, right? The corresponding value of y. Okay, so what we're going to do, we're just going to complete the squares, right? Okay, so like we said, we don't know that the ranges from what, but we know the maximum value is going to be 6 right here. The minimum point, which is right here, the corresponding value of y, we don't know it. So that's what we want to find. Okay, so we're going to complete this case. If you don't know how to complete this case, don't worry, you're in the right place. Okay, so let's complete this case. So this is the function that we have. We have x squared minus 5x plus 6. Okay, so what we're going to do, first of all, we're going to write x minus 5. That's what we have to write. We have to write these two terms and make sure that the coefficient of x is 1 right here. If it is 2, we use another technique. So let's write x minus 5. Now we're going to look at negative 5. That's what we look at. So we need to divide negative 5 times 2 and square it. So if you square negative, we're going to get a positive, which is going to be 25 over 4. And now we're going to add 25 over 4 right here and write positive 6, which we have right here. So as you can see, this one looks like this one, but there's a difference. We now have this term. So that means we have to subtract it so that we can return our original function. So let's subtract it and put the bracket right. Okay. So now, if you look at this, as you can see, 25 over 4, it has a square root, and the square root, that is 5 over 2. And if we say 5 over 2 plus 5 over 2, we get negative 5x. So that means we can write this as negative x minus 5 over 2 squared, right? If you write this, we're going to get this same expression, right? Okay, and right here we have 6 minus 25 over 4. So all you have to do is just take your calculator and are going to get negative 1/4. So this one is going to be the turning point, right? This is the turning point, which is going to be the minimum value right here. So now we have the minimum point, which say it's negative 1/2, right? So that means for our range, we can write f of x ranges from negative 1/4 to 6, right? Okay, I hope you've understood about the range. We're going to go to what we call composite functions. So for composite functions, what we're going to do, we're going to have two functions. We're going to have f functions, g functions, you can have h function, but we're going to have, you can have as many functions as possible, but in this case we're going to consider up to 3 functions. Like we always do, we're going to start with a simple, very understandable example, right? Okay, so given that f of x equals to x squared and g of x equals e to the power x, so don't worry about f of x and g of x, right? Just a letter that we have chosen, right? You can even replace f of x with the g of x, right? Okay, just a letter. nothing has changed right here. So this is an exponential function, right? And we're told that we need to find fg of x, right? So the layout right here, as you can see, this one is going to be the power function, right? So you need f of gx. So that means we're going to replace everything of x with g of x. That's what it means right here. Okay, so let's do that. We'll start with part A. So it said f g of x, that means we're going to replace this one with the g of x, right? Okay, and if we do that, as you can see, what is f of x? So f of x is x squared, but when there is x, we're going to put g of x, right? That's what we're going to put, right? And remember, this is squared, this is not affected right here, it's going to remain there. But what is g of x? So we have g of x right here. Okay, so now let's substitute, as you can see. And if we are good at laws of indices, it's just multiplying this exponent or the powers, and it's going to be e to the power 2x, and this is going to be a composite function. Let's go to part B. So for part B, we have g of x. Now g of x is now the power, so that means this one is going to become this one, right? And remember here we have e to the power. When there is x, that's where we're going to put g of x right here. Okay, so let's do that. You're going to have e to the power f of x, and f of x is x squared, and that is going to be the answer. Okay, I hope you've understood. This is mathematics. You have to master the concept, and after that you're going to be unstoppable. Now let's go to f of x equals x squared minus 1, and g of x equals to e to the power 2x. Yes, you can try this one. The good thing about mathematics, if you do a simple question, you are motivated. So now I want to find g f of gx and g of fx, right? Okay, so I'm going to repeat the same process. F of x is the power, so that means I'm going to replace this one with the g of x, right? So when there's x, we're going to put g of x, right? When there's no x, we're going to leave it like it is, right? Okay, so that means we're going to say gx squared minus 1, because this is where we have x, so we're going to put gx, and 1 is a constant. We don't have x, so we're going to leave it like it is. Okay, so now on gx we have e to the power 2x, but also have this squared, right? So let's substitute right here, and we said now we know that if we have powers, we can just multiply it, right? Okay, so we're going to have e to the power 4x minus 1. Now let's go to g of fx. Remember, g is not the power, so that means we're going to replace this one with f of x, right, which is right here. Okay, but remember, this one is g of x, so where there is x, we're going to put this whole thing, right? Okay, so now let's move on. We're going to have e to the power 2 of fx, right? Because we have 2 is not going to be affected, but when there's x, that's why we're going to put f of x. So let's substitute f of x with it right here, right? Okay, so this is what we're going to do. Okay, I think it's just good to leave it as a factorized form. That is the most recommended form, right? Okay, so now we're going to look at this one. Okay, right here we have a denominator, and don't worry. Yeah, okay, and we have a new thing here. X can be equal to 0. What does this mean? Okay, so we're saying that x can be equal to 0 because when x becomes 0, we're going to have 5 over 0. And 5 over 0, if you are new to mathematics, is equal to 0. But we know that 5 over 0 is undefined because the answer is going to be infinite. We don't have the answer to that. So we don't need 0 right here, right? So each and every time you have a denominator, know that the denominator should not be equal to 0 because the function will become undefined. So this is what it means, right? That means in whatever we do, we should not get 0 right here because we're going to have 5 over 0. If you punch on a calculator, on the automatic calculator, it will tell you error 1 or error 2, which means what you're doing is wrong. So that means you don't need a 0 right here. So this was just a guideline, and it is also, we can use this one to find the domain, right? You know, we need all values, right? Any value you can get here, but we don't need 0. So that means you can put 1, you can put 3, but when you put 0, everything will be bad, right? Okay, so for the domain, it's from negative infinity up to 0, but 0 is not going to be included, right? Then from 0 up to positive infinity, but 0 should not be included. And if something is not included, we'll put a bracket right here, this one. And if something is included, we'll put a square bracket right here. Okay, So we're going to look on that on the second chapter of this video, right? So this one just a basic introduction. So for the introduction, don't have to make things hard, right? So that people will be scared. Okay. So now let's look at our questions. So we have f squared x and fgf. Okay. So just relax. So for f squared x, so this one is same as saying f of fx, right? That's what it says. That's the same, right? As you can see, f times f is going to be f to the power 2. Since f is just f to the power 1 and f to the power 1, by laws of indices, we're just going to add. So just the symbol. So now what is happening right here? So that means this first f is the power. So that means we're going to replace this one with f of x. But what is f of x? It is also this one, right? So just going to duplicate right here. So let's write, we're going to say f of x, right? So for f of x, we have 2 to the power. What are we going to replace x with? We're going to replace x with f of x, right? For 3, just a constant, right? So I'm going to say 2, but what is f of x? So I'm going to put this one, this whole thing right here. So it's going to be 2 times 2x plus 3 plus 3. So now let's simplify. 2 times 2 is going to get 4. 2 times 3 is going to give us 6 plus 3, and that is going to give us 4x plus 9. Okay, as you can see, it was simple. I hope you've understood. And let's go to the last question, right? Okay, which is part B. Okay, so fg of f, right? Okay, so right here, what we need, let's do one thing at a time, right? So that we won't get confused. So we're familiar with this. We don't have any problem with this because we've been dealing with it right here. Okay, so let's do that. So from here, the power function is g. Remember, I have partitioned. We're going to stop dealing with this part, right? Okay, so the power function is g. So we're going to replace whatever in g with the f of x, right? Okay, so that's what we're going to do. So let's do that. Okay, g of fx. So we're going to say 5 over, because we have x right here. We're going to replace x with f of x, right? Okay, so let's do that. What is f of x? Is 2x plus 3. So it's going to be 5 over 2x plus 3. But let's not forget the original question. So that means we now have this one as well. We need to put it right here because remember we have forbidden this in the first place. So this one is now the power and this one is the function I want to replace it with. Okay, so for f of x, we know f of x is 2x plus 3. So whenever there is x, we now need to put this new value. Okay, just like that. It's going to be simple. Okay, so we have 2 plus 2x plus 3. So we're going to have 2 gf of x right here. Okay, so let's do that. We're going to have 2 gf of x plus 3. And this one is right here, right? We have nothing to worry. So let's just simplify here and substitute it. So we're going to have 2 times 5 over 2x plus 3 and plus 3. So I'm just going to say 2 times 10, right? I think that is good. We can leave it in this form if you want, right? Okay, or we can just simplify it and make it a single geometer. It doesn't matter. Okay, so that's all for the composite functions. If you have any question, put it in the description, right? Okay, so now on the inverse, I'm looking for the simple definition of inverse. Let's just say it's the opposite of a function, right? So inverse, that's opposite of what you are, right? That's what we call the inverse, right? Okay, so I'm going to draw simple graphs right here to demonstrate what is the meaning of the inverse, right? So I'm going to draw my x-axis right here. So I'm going to choose what is my favorite graph. I'm going to choose e to the power x, right? And the inverse of e to the power x, that is ln x, or the natural log of x. So this one is going to be the inverse. As you can see, just the opposite along the mirror line, which is going to be y is equals to x, right here. Okay, so as you can see, this one can be the inverse of this one, or this one can be the inverse of this one. Whatever way you want it to make sense, it makes sense. Okay, so what is the procedure of finding the inverse? So let's use this one as an example. I think 2 is what you are seeing is good. Okay, so let's say we have y equals to e to the power x and someone says find me the inverse. What do we do? Okay, that's what I want to do. So I want to use a very simple method, and this one is right. Yes. Okay, so what we're going to do, we need to interchange x and y, then make y subject to the formula, just like that. So what do we mean by interchanging? Okay, so by interchanging, where we have y, we're going to put x right here, and where we have x, we're going to put y right here, And after that, we have to make y squared with the formula just like that. Yes, just like that. Okay. So now, how do you make y squared with the formula? So you have to be good with equations. But if you are not, okay, let me show you how we can do it. Okay, so we need to drop the power. We need the power to the right here. Okay, so let's put the natural logarithm on both sides. So I'm going to put ln x and ln e to the power I right here. But in this case, we're very like y, because the natural logarithm of an exponential is 1, right? So that means we can place this with 1 and y will come down, right? Okay, so we're going to be left with ln x is equal to y, right? Just like that. And as you can see, we are back to where we started, right? Okay, but things won't be easy like this one. Okay, so let's look at another question, right? Okay, so you have y equals 2x plus 6. Let's interchange. Okay, so we interchange. Now x becomes y and y becomes x, like this one. And make y subject to the formula. So we're going to subtract 6 from both sides, and after that we're going to divide each and every term by 2, right? And this one will be the inverse of this function, right? Okay, as you can see, mathematics is like I said. Okay, so if you can subscribe to this channel, please just click the subscribe button, right? Okay, we have more things coming, right? Okay, now let's look at this question. Okay, so for this one, yeah, we're back to completing on squares. I know you don't like completing on squares, but that's what we want to do, right? Okay, so for this one, the best way, if you want to make y subject formula right here and just interchange this thing, it will be difficult. But if you complete the squares, you will remove this x squared, right? Because from here, you know, you have to solve a quadratic equation, something that is very, very difficult. So let's complete the squares, right? Okay, so 6x divided by 2, that's going to give us 3. 3 squared is going to give us positive 9, right? So I'm going to say x squared minus 6x plus 9 plus 10, right? But remember, 9 was not there in the first place, so that's why we subtracted it, changing the appearance, but the value remains the same, right? Okay, so from here, you can see that if you complete the square from here, it's going to be x plus 3 squared, right? And later, when you have 10 minus 9, that's going to give us 1. So let's do that. So we're here, and this is what we're going to get, right? Okay, so now it's now a matter of interchanging. Okay, so let's interchange our values right here. Okay, so for x, we're going to put y. Okay, so let's do that. Okay, so we're going to have x equals to y minus 3 squared plus 1. And don't expand, because if you expand, you're going back to the original problem, which we avoided. So now we're going to subtract 1 on both sides, right? Okay, but we have y minus 3. What are you going to do? So you can remove this by taking the square root on both sides. Yes, we can do that. And this one's going to be our answer right here. Okay, but we have left with one thing. Remember, we have negative 3 here, and it should be positive 3 if you move it to this side, so that we can be left with y. And now this one becomes our inverse, right? Okay, that is good. Okay, so what if we have a function like this one? Okay, it's easy, don't panic. Okay, so what we're going to do, we're going to interchange x and y, then make y subject to the formula, right? So it's going to be x is equal to 3 to the power y. Now, let's check the logarithm on both sides. So we're going to have ln x is equal to ln 3 to the power y. Okay, so from here, you can see that we can drop the power, and we're going to have ln x equals to y ln 3. And now, we need to divide both sides by ln 3. And if we do that, we're going to have our y. And this becomes the inverse. But some people may not like this form. Okay, so they may want to take it from here, right? So from here, as you can see, so this is an expression you should be familiar with, right? So if you make y such as the formula, we're going to have log, this one will become the base, right? And this one will become the log. So we're going to have log base 3x. Let's do that. It's going to be log base 3x, right? So this one and this one just the same. Choose what you want. Okay, so thank you for watching. Don't forget to subscribe.